Yeah. See, we know that as per multiplication theorem, probability of A given B, how we can write? Probability of A intersection B upon probability of B. So whatever the given event, that will be comes in your denominator. Okay. So first option, let it be first option. What has been given? Probability of A given B is equal to 0 has been written. So I can write probability of A intersection B upon probability of B. So can I write based on this? Probability of A intersection B is equal to 0, because probability of B, it must be strictly greater than 0. So it cannot be 0. So that probability of A intersection B will be 0. Got it? Then similar way from this one here, probability of B given A is equal to, I can write probability of B intersection A upon probability of A. So here B given A, sorry, B intersection A or A intersection B, both are same because of the commutative law that we have already we have written in the set theory. A intersection B is equal to B intersection A. Okay. So probability of A, definitely it is greater than 0. So now this based on this also, you can say it's a probability of A intersection A is equal to 0. Based on that, this also equal to 0. So that the first option is right. First option is correct. Then coming to the second option, so let it be probability of A intersection B is equal to probability of B. Based on this option, what does it mean? Probability of A given B is equal to, I can write probability of A intersection B upon probability of B, which is equal to 1 as per given, which means probability of A intersection B is equal to probability of B. Right? So coming to this one, probability of B intersect B given A. What do you write? Probability of B intersection A upon probability of A must be equal to 1. It has been written. Okay. So what does it mean? Okay, I'll go further. Wait. So here, probability of B intersection A is equal to probability of A. So B intersection A, I can write, or else I can write let it be. Probability of B intersection A upon probability of A. I can write B intersection A, already you have written. What is right? Probability of B by probability of A. So it is not at all equal to 1, because not necessary to be equal to 1, because probability of B is existent in the probability of B intersection A or probability of A intersection B. Both are same. So that's why probability of B by probability of A is not equal to 1. So this is wrong. This is the wrong option. Coming to the third one, third option, probability of A given B is greater than probability of A, it is written. So can I write this one? Probability of A intersection B is equal to probability of A into probability of B. So not is equal to, it's greater than. It's greater than. Okay. Probability of A intersection B is greater than probability of A into probability of B. Coming to the second one, probability of B intersection A is greater than probability of A into probability of B again. Even from this one also. You can write from this one also. From this one. This. Probability of B intersections. So both are same. So this is correct answer. Coming to the fourth one. Probability of A given B greater than probability of B, it has been given. So probability of A intersection B is greater than probability of B whole square. Right? Coming to this one. Probability of B given A is greater than it has given probability of A. B given A, can I write probability of B intersection A con probability of A, which is greater than probability of A. So B intersection A is greater than probability of B. That means which is greater than probability of B whole square upon probability of A. It's not B probability of greater than probability of A. So your fourth option is also wrong. So the correct options are A and C. Got it? Yes. In this any doubt, please let me know. Okay. So I'll give another example based on this one. So this question has asked in the June 2019 CSIR. Yeah, it has been asked in June 2019 CSIR question. There are 30 questions in a certain multiple choice examination. Each question has 4 options and exactly one is to be marked by the candidate. Okay. 3 candidates. Sorry. 3 candidates A, B, C mark each other. Sorry, mark each question. Mark each question of 30 questions. 30 questions randomly, random independently, you can write. Random independently. The probability that all the answers of the 3 students match each other perfectly is option A minus 4, option B 30 power minus 4, option C is 4 power minus 30, option D is 4 power minus 60. There are 30 questions in a certain multiple choice examination. Each question has 4 options and exactly one is to be marked by the candidate. Okay. So there are 3 candidates, A, B, C. So they are writing the questions 30 random independently. They are writing all the questions. So the probability of all 30 questions of 3 candidates match is that where they are matching all 3 options correctly of 30 questions. So what will be the probability? Try it. So this is based on simple probability only, not we'll go with any Bayes theorem like that. Simple probability where either no much thing will be different. Just it's a multiplication theorem, let me you can say, because of the independent, randomly independent, you can say. It's a multiplication theorem there. If A intersection B, A and B are independent, then we can write probability of A into probability of B, like that. That we know that probability of A intersection B is equal to probability of A into probability of B if A and B are independent. So based on this only, it has written randomly independent. Okay, randomly independent. Any guess? You can send your answer in chat box also. Okay. Okay.
C.
Okay.
Vedavati responded Srivendra Reddy, Harshavardhan, Harika, Ramya, Uharani responded Soumya, Lalini.
Okay. I'll solve this question. See, first is probability of getting correct answer. How much? What is the probability of getting correct answer? It is 1/4 because you have 4 options in a multiple choice question. Each question. Okay, 4 options. So we have to find out what we have to find out there. Probability of perfectly match the answer. This is what we are going to find out. So how many cases are there in the where the three students have the same options? Okay. The first case, when all candidates tick option 1. There are 4 options, right? Option 1. The second case, when all the candidates tick option 2. Okay. Third case, when all the candidates tick option 3. And then fourth one is when all the candidates tick option 4. Other than this, do you have any? Only these four possible things or 4 possible ways that all the candidates will have the same correct answer. Exactly match their answers. Means that person A as option 1 and person B option 1, person C also option 1, then only their answer will be matched. Either it is correct or not, doesn't matter. Perfectly match the answer. Okay. So here, let it be from this. From A, B, and C. So person A choose an option 1, person B choose an option 1, and person C choose an option 1. So for choosing option 1, it is 1 by 4. This is also 1 by 4. This is also 1 by 4. And it is already clearly says that they are independent. As you know that probability of A intersection B intersection C, we can write probability of A into probability of B into probability of C. So based on this, I can write 1 by 4 into 1 by 4 into 1 by 4. Right? For the second option, similar way, 1 by 4 into 1 by 4 into 1 by 4. Third option, same thing. Fourth option also same thing. Okay. So, because they are independent, I can say that 1 by 4 cube plus 1 by 4 cube plus 1 by 4 cube plus 1 by 4 cube. There are 4 options. For first option, second option, third option, and fourth option. So it is 4 by 4 cube. This I can write 1 by 4 square. So this is for question 1. This is for question 1 only. So what about the 30 questions? We have there are 30 questions. So your answer will be 1 by 4 square power 30. That we can say 4 power minus 60. What is the right answer? This one. Fourth one is the right answer. Got it? Any clarification required in this question?
Okay, Nandi. Any more doubts?
Any clarification?
Clear, sir.
Clear?
Okay. Okay. Go ahead, sir.
Thank you.
డౌట్స్ ఉంటే మీకు అడగండి, క్లారిఫికేషన్ ఎక్కడన్నా ఉన్నా అడగండి, సార్ అలా ఏం ఫీల్ కాడు. ఓకే, నో డౌట్స్, వెరీ గుడ్.
Okay. So we'll start. Bayes theorem. So definitely you can expect 1 or 2 questions from Bayes theorem, guarantee. At least 1 question. Out of
డైరెక్ట్ కూడా అడగొచ్చా సార్? డైరెక్ట్ స్టేట్మెంట్ మీద కూడా అడుగుతారా సార్?
స్టేట్మెంట్ అట్లనే ఉండదు.
అప్లికేషన్స్
అప్లికేషన్ అదే జస్ట్ క్వశ్చన్. ఇప్పుడు నేను ఆ క్వశ్చన్స్ కూడా ఒక 2-3 క్వశ్చన్స్ ఉన్నాయి బేస్ థియరం లో. I will explain it.
థ్యాంక్ యూ.
So first statement. What is the statement of Bayes theorem? If E1, E2 and so on, En are mutually disjoint, events with probability of EI not equal to 0. Okay, I range from 1 to n. Then for any arbitrary event, capital A, which is subset to the union of EI, such that probability of A is strictly greater than 0, then we have probability of EI given A is equal to probability of EI into probability of A given EI upon probability of EI into probability of A given EI. This is summation I ranging from 1 to n. Or simply to write sometimes probability of EI into probability of A given EI upon probability of A. I'll clearly explain about the statement of this Bayes theorem, because definitely you can expect the questions from Bayes theorem. That's why we'll explain you again and again in this statement, that if you clear about the statement, then you can easily answer. 1 minute. Yeah. I think now my voice is clear.
Yes, sir.
Yes, sir.
Yeah. See, E1, E2 and so on, En are mutually disjoint events. Okay. So let it be, if I draw any diagram like that, this is an arbitrary event. Okay, you can write E1, E2 and so on mutually disjoint events, probability here, which is subset to the sample space. Definitely it is subset to the sample space. You can write here, they are subset to the sample space. Okay. So you can write this is like that, and events. You can say this is event 1, this is event 2, and so on. This is event n. There are n mutually disjoint because they are not joined each other. And A is a subset of union of EI. This A is an arbitrary event which is union of EI. The statement is here E1, E2, and so on, En are mutually disjoint, and A is an arbitrary event which is subset to the union of EI. What does that mean? A is subset to the union of EI. That is what he has written, right? A is subset of union of EI. Then what does that mean by A? Where you can draw the A? See, A is a subset of union of EI. Then what is A? Can I write A is A intersection union of EI? Because A is a subset of union of EI. Then I can draw A is A intersection of union of EI. So from this, can I write this one? A intersection EI by distributive law. Okay. A is union of I range from 1 to n, A intersection EI. See, A intersection E1, A intersection E2, okay, and so on, are subset of EI, or I can say simple, right? A intersection EI is subset of EI, and simple thing you can say A intersection E1, you can say itself here, A intersection E1, A intersection E2, and so on, A intersection En. These are all the disjoints. A intersection E1, A intersection E2, A intersection E3, all are disjoint. So as per the axiom, this, how I can write? Probability of A is equal to probability of union of I ranging from 1 to n, A intersection EI. Can I write this one? Probability of A is equal to summation I ranging from 1 to n, probability of A intersection EI. So A intersection EI, based on multiplication theorem, where you can write summation I ranging from 1 to n, probability of EI, probability of EI given, sorry, probability of A given EI. Wait, I will write again. Yeah. There I can write probability of EI into probability of A given EI. Simple. Probability of A intersection, like I can write here. Probability of A intersection B is equal to probability of A into probability of B given A, or probability of B into probability of A given B. Either side you can write as per multiplication theorem. Okay. So one side I have written this one probability of EI into probability of A given EI. This is probability of A. This is probability of A. So coming to another way, you can write probability of A intersection EI. Another way you can write probability of A into probability of EI given A. Okay. So or else probability of EI given A is equal to probability of A intersection EI upon probability of A. Got it? So this one I can write probability of EI, probability of EI given A upon probability of A. This is probability of EI, probability of EI given A upon summation probability of EI, probability of EI given A. So this is the Bayes theorem statement. Simple, I can say Bayes theorem is the extension of multiplication theorem. Only thing is one or two events are depend upon, the one or two, more than two events or more than one event depend upon some particular event, then you can go with the Bayes theorem. Actually, multiplication of only two events, but Bayes theorem, more than two events will come into the picture. Then conditional probability will be applicable where more than two events are existence at that. Okay. So we'll solve our problem on this. Yeah, somebody is trying to speak.
Sir,
Yeah.
sir, last step lo right side EI by A na A by EI, sir?
Last step.
A by EI kada, sir? Last step.
Sorry. Wait. Yeah, sorry. ఇక్కడ A by EI, ఇక్కడ కూడా A by EI. Thank you.
Okay, sir. Okay.
Okay. So we'll solve a problem on this. Yeah. A bag contains let be one, contains 4 white and 6 black balls, while another bag 2 contains 4 white and 3 black balls. So here one ball is drawn at random. From one of the bags. From one of the bags. And it is found to be black. So what is the probability that it is drawn from bag 1? So 2 bags are there. One bag contains 4 white balls and 6 black balls, and another bag contains 4 white and 3 black balls. So firstly, we have drawn one ball is drawn from random or drawn at random, and we found it is black. Then what is the probability that that black is from bag 1? Okay. So we'll solve the problem. So we can take E1 be the event choosing bag 1 and E2 for bag 2. Capital A is event drawing black ball. That's it. So we know that probability of E1 is equal to probability of E2, that is half, because any one bag can be chosen. Maybe it may be any bag. So it has been given that probability of A given E1. What does it mean? Probability of A given 1, which is probability of drawing black ball from bag 1. What is the black ball from bag 1? How many black balls are from bag 1? There are 6 balls, right? So out of how many balls in bag 1? 10 balls. 4 plus 6 10, and bag 2 4 plus 3 is 7.
7.
Okay. So here 6 by 10, that you can write it as 3 by 5. Then probability of A given E2. There you can write it's a 3 by 7, because 3 black balls and 4 white balls in the bag 2. So using Bayes theorem, you can write directly probability of E1 given A, because the black ball which should be from bag 1, that is I can write probability of what is the bag 1 and probability of the black ball which is from bag 1 upon total, that is what probability of E1 probability of A given E1 plus probability of E2 probability of A given E2. Okay. So this is probability of E1, it is 1 by 2 into A given E1, it's a 3 by 5 upon, so 1 by 2 into 3 by 5 plus probability of E2 is 1 by 2 into A given E2,
3 by 7.
3 by 7. So total I can get 3 by 10 and then some, okay, sorry, 7 by 12. So this is the correct answer. So Now I'll give the question from CSIR examination. Yeah. Same thing. Similar question only. You can write, you can ask answer easily. Let me check whether how many people will write correct answer. This question is December 2019. CSIR. Okay. Question is, there are 3 arms U1, U2, U3, each with balls of 2 colors. Okay. U1 contains 2 white and 3 black balls. Then U2 contains 3 white and 2 black balls. Then U3 contains 5 white and 5 black balls. Got it? When urn is chosen at random, an urn is chosen at random, and ball is drawn from that urn. From chosen that urn at random. It is also chosen at random only. Okay. So what is the probability that U2 was chosen? U2 was chosen given that ball is black. It is similar, whatever we have solved the previous question, exactly similar one. So give me the answer. These options has been given. Option A is 1/3. Option B is 4/15. Option C is 2/15. Option D is 1/6. First, you can solve using Bayes theorem, and I will show you the shortcuts how you can solve within short period of time. The same question. Option B. Okay. Option B. Very good. Option B. Very nice. Okay. Any guess? Only 1 or 2 people are responding, then what about others? Okay, Soumya option B. Any other?
Option B, sir.
Yeah. So you have solved by your own. So now I'll give you the shortcut. Okay. See, there are three urns. U1, U2, U3, right? So all there choosing any urn is 1 by 3, 1 by 3. So from urn it is black. Okay. So urn 1, how many blacks are there? 3. Urn 2, 2. Urn 3, 5. So total is 5 balls in urn 1, 5 balls in urn 2, and 10 balls in urn 3. So here so this is 3 by 5. This is 2 by 5. This is 5 by 10. So this implies, so urn 1, then black, conditional probability, that is 3 by 5 into 1 by 3, that is 3 by 15. This is 2 by 5 into 1 by 3, that is 2 by 15. From this, 5 by 10 into 1 by 3, that is 5 by 30. So total will be 15 by 30, that is equal half. So which is from second urn? The probability is which is from second urn. Okay. You should make where it is from second urn. So you can write simple this one upon this one. That is 2 by 15 upon 1 by 2, that is 4 by 15. This is the right answer. Just 1 minute or 2 minutes, you can solve the question. Simple. So this is, I think you have understand this question. I'll write another question. So these type of questions you can expect more. This is asked in (2020) CSIR. Okay.
Sir, once scroll down, sir, please.
Yeah.
Madam, also sir send the notes also.
Okay, sir. Thank you.
సార్ మీకు నోట్స్ కూడా ఇస్తాను.
యా నేను పంపిస్తానండి, మేము నోట్స్ పంపిస్తాను. అట్ ద సేమ్ టైం ఈ క్వశ్చన్స్ కింద కూడా పంపిస్తాను. సాల్వ్ చేసింది అంటే నా స్టైల్లో సాల్వ్ చేసినవి మోస్ట్ ప్రాబబ్లీ ఇలాగే ఉంటాయి. అంటే మీకు ఈజీగానే అర్థమవుతుందని నేను అనుకుంటున్నాను. ఓకే, మీకు అర్థం చేసుకోవడానికి ట్రై చేయండి. ఫస్ట్ క్వశ్చన్ నేను రాసుకునేటప్పుడే మీరు సైమల్టేనియస్ గా సాల్వ్ చేసేసేయండి, మీకు ఈజీగా ఉంటుంది. సేమ్ ఇప్పుడు నేను ఎలాగైతే షార్ట్ కట్ లో సాల్వ్ చేశానో అలాగే సాల్వ్ చేయడానికి ట్రై చేయండి ఈ క్వశ్చన్. ఇన్ అన్ ఎగ్జామినేషన్ ఇన్వాల్వింగ్ multiple choice questions. Okay. A student works out works out the solution in 50% of the questions. In remaining questions, the student guess the answer. Student guess the answer. However, when the answer is guessed, the probability that it is correct is 0.3. Means that 30% of the time, if you guess, the question will be correct. When the student works out the solution, it may be wrong. It may be wrong with probability 0.1. If answer to a particular question is correct, what is the probability that the student guessed the answer? Option A is 0.25. Option B is 0.5. Option C is 0.9. Option D is 0.3. So correct answer. So when is provided that it is correct. So you have to find out probability of guess the answer when it is correct. So you can make in two branches, that works out and guess. Will you give the answer or have to solve? See, what we have to find out? Probability of guess the answer when it is correct. Okay. So we have two options. One is the student is workout. Second one is he guesses. So 50% of the time he workouts, right? So this is 1 by 2. This is also 1 by 2. That is a 50% of the time. 0.5, 0.5. Okay. So it must be correct. This must be correct. So wrong one, it has been given that 0.1. So 1 minus 0.1, that is 0.9. Here 0.3. It has been given that 30%. When the answer is guessed, the probability that is correct is 30%. So this one will be 0.9 by 2. This will be 0.3 by 2. So total is 1.2 by 1.2 by 2. So your probability of guess given it is correct. This one. From this, it is 0.3 by 2 upon 1.2 by 2. That is 1 by 4. So option A is correct. Okay. The remaining practice questions I will send you by this one. I will share the notes, no problem. Okay. So now we'll discuss the new topic. That is random variables. So earlier we have discussed about the simple probabilities only. So now we are going to discuss about the random variables. Okay. So random variables, just simple is random variable is a function of outcomes. I can say the mapping, just earlier we have made sample space, all the outcomes. You can say tossing a coin, casting a die, drawing a card from 52 deck of cards. These are all the outcomes, which is sample space that we have written head and tail, or two coins simultaneously, HH, HT, TH, and TT. So this is only the way that we are going to draw the probability from this one. మనం ఇక్కడ మాత్రమే డ్రా చేసుకున్నాం. నేనేమంటానంటే ఇక్కడ ర్యాండమ్ వేరియబుల్ వచ్చేసరికి ఈ ర్యాండమ్ వేరియబుల్ ని రియల్ ప్లేన్ లో మనం చూస్తే ఎలా ఉంటుంది అంటే ర్యాండమ్ వేరియబుల్ లెట్ x which is mapping from sample space to the real. Mapping from sample space to the real. I'll give an example of that, why it is sample space to the real. You can understand easily, you never forget about this. I'll give an example. Let it be a die experiment. Okay. How many outcomes are there? Die experiment. F1, F2, F3, F4, F5, F6. So this is the sample space in a die experiment. This is the outcomes, you can say. Outcomes. Okay. Means that 1, 2, 3, 4, 5, 6. Generally, we are going to draw the probabilities in whatever addition theorem, multiplication theorem, Bayes theorem, this and all. We are trying to draw from this one. Fi is equal to some 10 into I. Here, your 10 is R. 10 is real plane. Okay. Which means instead of discussing about the probability of getting at least any number, any number phase, like 1, 2, 3, 4, I will ask getting at least 30 rupees, getting at least 40 rupees, getting at least 60 rupees, like that. Which means I can give you that, I can say, I will ask that so what is the plausible outcomes, or what are the possible outcomes that if you gain at least 35, this is 10 is means that, let it be, you are casting a die, I'll give 10 rupees on a number which is up here. Let it be, first time you toss you cast a die, you got number 2, I'll give 20 rupees to you. And second time you got number 5, I'll give 50 rupees to you. At the maximum, I can give 60 rupees, minimum 10 rupees. Minimum 10 rupees, maximum 60 rupees. So instead of discussing about what is the probability of getting number 4, getting number 6, getting number 3, getting number 1, I'm discussing about what is the probability that at least 35 rupees you are gaining. Get my point? You are gaining at least 35 rupees, or maybe 40 rupees, exactly 30 rupees, exactly 40 rupees, like that. Okay. So here, so what is the one? What is the sample space here? F1 will come, F2 will come, and F3 will come. And let it be another case. X is exactly equal to 35 rupees. Exact 35 rupees. Any other sample space is there in that? No. So I can write this null. Even X is less than or equal to 5 rupees. I've already told you that minimum 10 rupees I can give, because your function is 10 into I. 10 into I. Minimum 10 rupees I can give, maximum 60 rupees. So this implies X is equal to infinity and X is equal to minus infinity will be null. Okay, means that your sample space going to defined on the real plane. So which means this X, okay, this X is a function of outcomes. I can write it simple. X of omega is less than or equal to small x. Omega is the outcomes. Omega is outcome. X is a representation of random variable, and this is your real or capital R. So I can write your random variable is a function of outcomes which is less than or equal to real. So definitely this entire thing can I write as an event? Can I write as an event? Okay. So your random variable defined on, okay, defined on same, whatever the probability space is defined on that is sample space, sigma algebra or Borel field, and probability measure. Okay. And then you can make it in a properties of this one. You should remember all these properties, or you can note it down, and then I'll send you the notes also. Let it be a function x of omega. Okay, function f of omega from S to R. So R is range from minus infinity to plus infinity, is a random variable if it is your omega, that is x of omega is less than a real value which belongs to your sigma algebra. And second one is x1 and x2 are two random variables and C is a constant. C is a constant, then Cx1, comma, x1 plus x2, x1, x2 are also random variables. So these properties will be applicable while you are going to solve the problem in conditional probability. So that's why you should remember the random variable properties. If x is a random variable, let it be random variable, then 1 by x, where 1 by x of omega is equal to infinity if x of omega is equal to 0. Or you can write x plus omega is equal to, we can write maximum of 0 comma x of omega, and x minus omega you can write minimum of 0 comma x of omega. Even mod x also is a random variable, you can write. Another thing is, if x1, x2 are two random variables, then maximum of x1, x2 and minimum of x1, x2 are also random variables. This is important. If x is a random variable and the function f dot is a continuous function, then f of x is a random variable. Even if it is f dot is the increasing function, f of x is also random variable. Okay. So these are some properties of random variable. So now once you have defined the random variable, then you have to discuss about distribution function. Sometimes you can write it is cumulative distribution function. Okay, CDF, cumulative distribution function. Now we can write simple thing. Simple definition of distribution function is probabilistic nature of random variable. What does that mean? Probabilistic nature of your random variable is your distribution function. Simple. This is your distribution function. Probabilistic nature of random variable is a distribution function. Give an example. What is a distribution function? Give an example here. Let's consider tossing a coin. Okay, coin tossing. Coin tossing example you can take. Okay. let x of head is 1 and x of t is equal to 0. Okay, x of h is equal to 1 and x of h is equal to 0. The first one is x is greater than 1. Second one is x is less than or equal to a, where for every a is greater than or equal to 1. Third one is x is less than or equal to b, for every b is lies between strictly less than 1 and greater than or equal to 0. X is less than or equal to c, for every c is strictly less than 0. Greater than 1, simple. Your random variable never be greater than 1 or your x value is never be greater than 1. Then simple it is 5. X is less than or equal to a, where a is greater than or equal to 1. What does it mean? X is less than or equal to 1 here. So what is the possibilities of here? H comma t. And here x is strictly less than 1, means that it won't be coming to here. Simple it is t, sorry, and this is null. Means that you can get it is 1, this is 1 by 2, this is 0, this is also 0. Okay, means that your distribution function starts from exhaust case it is 1 and in between it is off, and otherwise it will be negative side, it will be 0, simple. Okay, so the properties of the distribution function, simple properties. First property is, if f is a distribution function of random variable, f is a distribution function of a random variable x, and if a is less than b, then probability of a is less than x is less than or equal to b, we can write f of b minus f of a. I think no need of the proof of this one, just you can remember the one. No need of the proof. The second property, if f is a one-dimensional random variable, if f is a distribution function of a one-dimensional random variable x, then 0 is less than or equal to capital F of x is less than or equal to 1. Second one, f of x is less than or equal to f of y if x is less than y. Okay, if x is less than y. So this you know that because probabilistic nature of a random variable, this is what you can write, probability of x is less than or equal to small x, the definitely it is a probability value lies between 0 and 1. This will be valid. It is non-decreasing monotone. X is less than y, non-decreasing monotone. Your distribution function is always non-decreasing monotone. And third property, is f of minus infinity is equal to 0 and f of plus infinity is equal to 1. What does it mean? Limit x tends to minus infinity f of x is equal to 0. This is limit x tends to infinity, f of x is equal to 1. Okay. So this is the distribution function properties. Just you remember these three properties of distribution function. And now we are going to discuss about random variables. Are two types again. Random variables are two types again. One is discrete, other one is continuous. Okay, what does it mean by discrete? Countable number of values. Means that your random variable is countable number of random variables, then you can say it is discrete. Or else if it is a continuous, means you are describing your random variables within certain intervals. That is continuous. Okay. So tossing a coin, getting head and tail, it is a discrete only. Simple. You are getting head and tail, it's a discrete, simple, discrete numbers, you can get it. So based on that, you can say it is a discrete random variable. If it is a continuous, means you are defining on a particular subinterval. Some intervals, you are defining your probabilities in this some interval, then you can say it is continuous random variable. Okay. So now we can write discrete random variable. With that, we're going to write probability mass function, or simple we can write PMF, probability mass function. Just because of the discrete, you are adding all together. Okay, you are adding all together, it is a mass. Otherwise, it is density. Okay, if it is a continuous case, you can get it a density. Because of the discrete case, you are making it a mass. That's why you will write it's a mass function. So suppose you can write, you can say it's a, suppose capital X is a random variable, as a discrete random variable, and the values of x1, x2, and so on, xn. Each possibility of outcome. No? x1, x2, and so on, xn, or maybe don't remember this, just x1, x2, and so on, xn. Each number we are assigning one probability. Each number we are assigning one probability. Let it be that probability, you can say it is a pi. We can write probability of xi is equal to, probability of x is equal to xi, or simple I can write p of xi. Means that you are giving each and every value of a random variable or every value of a discrete number, you are giving some probability. Means that at particular 1, you are giving some probability, particular 2, you are giving some probability, particular 3, you are giving some probability, particular 4, you are giving some probability, like that, and so on. So each number of your discrete numbers, discrete random variables, you are giving some probabilities there. So we can say it is probability of discrete random variable, or you can say probabilistic nature of a discrete random variable is your probability mass function. I can say probability of discrete random variable is your probability mass function. So it must be satisfies a conditions. First one, what is the condition? Because of the probability, your p of xi must be greater than or equal to 0. Okay, for every I. And second one, total probability must be equal to 1. Why it is must be equal to 1? Because it is a mass and it should not be it should not be not greater than 1, because it's a probability value. So I already told you that probability for sure events is 1 and Impossible event is 0 means a not defined value is 0, then your probabilities lies between 0 and 1. It will be cumulated all these things. All summation of your probabilities of discrete random variable or of a random experiment, it will be equal to 1. Okay. Now, from this, we can draw the discrete distribution function. How you can write discrete distribution function? That is, capital F of x is equal to, I can write summation over I, that is xi is less than or equal to small x. It's a pi. What does that mean? Let it be, you can take a graph of this one. From this 1, 2, 3, 4. You have a 4 random variables, and this is your distribution function of x. So every random variable you have one probability. Okay. Every random variable you have one probability, and second probability up to second you reach the same probability will be hold. Once you reach the second one, suddenly it jumps to the another one, and then next, and then next, like that. So it's a, I've already told that it is a non-decreasing monotone. Your distribution function is non-decreasing monotone. Your distribution function is non-decreasing monotone. That's why your discrete probability mass function, you can say it's a discrete random variable, and distribution function is summation over x pi. That's it. So if you want, you can solve an example on this discrete one. Otherwise, we'll go for continuous one. Continuously. Yeah, we'll go for continuous. Sorry, we'll solve one problem. Let it be. See, the random variable x following the distributions x and their probabilities. If it is 0, your probability will be 0. If it is 1, probability will be k. If it is 2, probability will be 2k. If it is 3, probability will be 2k again. If it is 4, probability will be 3k. If it is 5, probability will be k square. If it is 6 random variables, it is probability will be 2k square. If it is 7, your probability will be 7k square plus k. So from this, first you can find the value of k, and second one, find the probability of x is less than 6, x is greater than or equal to 6, and probability of 0 less than x is less than 5. Okay. And third one, if probability of x is less than or equal to c is equal to half, sorry, is greater than half, what is the value of, what is the minimum value of c? And final, describe the distribution function. So the first question, because we know that total probability, that is summation I ranging from 1 to 7, because there are 7 numbers, p of x must be equal to 1. Okay, p of x must be equal to 1. What does it mean, p of x must be equal to 1? This implies k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k must be equal to 1. So this I can write 10k square plus 9k minus 1 is equal to 0. Just you can say 3 plus 2 5 plus 3 8 plus 9 9k 7 plus 3 10k square minus 1 you can get here. So here roots you can get 10k minus 1 k plus 1 is equal to 0 because k plus 1 is equal to 0, which means k is equal to minus 1. So because of the probability, so probability values must be greater than or equal to 0. So this case not valid. So only one case is valid, that is 10k minus 1 equal to 0, that is k is equal to 1 by 10. Okay, k is equal to 1 by 10. This is only the valid of, because whatever the k value, it must be lies between 0 and 1 only. Should not be greater than 1. And second question, probability of x is less than 6. What does it mean? Probability of x is equal to 0 plus probability of x is equal to 1 plus and so on plus probability of x is equal to 5. Okay. So even there here only you can find out your based on this you can find out here it is 0, 1 by 10, 2 by 10, 2 by 10, 3 by 10, 1 by 100, 2 by 100, and 7 by 100 plus 1 by 10. You can write 17 by 100. Okay. So this is your original p of x. After finding your k value, this is p of x. Okay. So what is capital F of x? You can find out. After that, you can find later. What is f of x? 0. First one will be 0. Second one 0 plus this one. It is 1 by 10. Next one
3 by 10.
1 by 10 plus 2 by 10, that is 3 by 10. 3 by 10 plus 2 by 10, it is 5 by 10. 5 by 10 plus 3 by 10.
8 by 10.
8 by 10. Then 8 by 10 plus 1 by 100, it is, you can say it is 81 by 100. 81 plus 2, it is 83 by 100. Plus 70, it is 100 by 100. That is what we read. F of infinity is equal to 1 all the time. And f of minus infinity is equal to 0. That has been written in the properties of distribution function. Okay. So similar way, here x equal to 0, it will be 0, x is equal to 0, and x is equal to 1, 1 by 10, 2 by 10, 2 by 10 plus 3 by 10 plus 1 by 100, that you can get 81 by 100. Or simple, you can see there, in probability of x is less than 6. X is less than 6. This was your x is less than 6. Greater than or equal to 6. 1 minus of this one you can get, that is 1 minus 81 by 100, that is 19 by 100. Okay. So where you can get x is lies between probability of 0 less than x is less than 5, which means x is equal to 1, x is equal to 2, this one. This one. So there you can get it is 4 by 5. And third question is probability of x is less than or equal to c, which is greater than 1 by 2. Where you can get greater than 1 by 2? Where you can get greater than 1 by 2? From this it is 1 by 2, greater than 1 by 2. Where you got? At 4. That is at c is equal to 4 I got. My probability is greater than 1 by 2. Up to that it is less than 1 by 2 only. Up to 3 it is less than 1 by 2 or less than or equal to 1 by 2. Strictly greater than 1 by 2 it is at c is equal to 4. Okay. So now coming to the continuous random variable. Continuous random variable. When you are going to define a random variable in a particular interval, means that if you are finding or you are trying to estimate the temperature of a room temperature, then it is lies between some interval. That is lower limit, upper limit will be there. There you can find out your probability. Means just simple continuous means it's a continuous process which is not having any exact number in the particular random experiment. A random experiment which doesn't have any continuous one. And if you are defining the probability on a particular continuous random variable, then you can say it is a probability density function, or simply you can say probabilistic nature of continuous random variable. This is continuous. Then I can say it is probability density function, PDF, probability density function. Or I can define simple thing. It is probability of x is less than capital X, or sorry, less than or equal capital X is less than or equal to x plus some delta x or some dx. Or you can say it is, let it be here. This is a function, let it be, this is y is equal to f of x function. So you are defining on particular interval. This is x and this is x plus delta x. So this entire density you can say it is f of x dx. Or you can say it's the limiting case that we hope you remember that. Limit delta x tends to 0. Probability of x is less than or equal to capital X is less than or equal to x plus delta x upon delta x. What does it mean? This is density function. Probability density function. Simply I can write it is fx of x. Okay. So density function, because of the density function, it must having some properties. The first property will be f of x must be greater than or equal to 0 because it is defined on the random variable. And second thing, integral minus infinity to plus infinity, f of x dx must be equal to 1. Total probability should be equal to 1. Let it be in case of discrete variable, in case of discrete random variable, probability of x is equal to c is exists, right? X is equal to c exists. Or else, second thing, if it is a continuous, it's a continuous random variable, probability of x is equal to c is always 0 for every c, where c is a constant. Okay, c is a constant. Both the case means that In discrete case, it will be like this. Okay, it's a discrete case. It's the x values. This is the small x, small p of x. In continuous case, you are giving like this. Okay, you are making like this. Okay, your density function is depend upon lies between x and x plus delta x. This is your f of x dx. See, this is 1, this is 2, this is 3. At a particular value, your probabilities exist. Let me, this is 1, this is 0.8, and this is 0.2. Okay, 0 to 0.9999, all the time your probability will be 1. Once it is jumped to the 1, your probability reduces to 0.8. 1.2, 1.3, 1.4, your probability will be exist there because it's a discrete random variable. I'm telling you, discrete random variable. But coming to the continuous random variable, at a particular point, some c. What does it mean by some c? And particular point, some c. At a particular point c, simple like my meaning is that what is the area under the particular point? It's all the time it will be 0. It's not defined. So in continuous case, we are all the time we are making x lies between some interval x and x plus delta x. Okay, at particular point you can't get any even single quantity, single probability there. So that's why you should remember, if x is a continuous random variable, probability of x equal to, if it's right, x equal to in continuous case, all the time it will be 0 only. All the time it will be 0. If it is a discrete case, it exists something else. At one point, it's let me, it is 0.5. At particular 0.5, x is equal to 0.5. Your probability will be x is equal to 0.5. The probability is 1 based on this graph. At probability at x is equal to 2.4, that is probability of x is equal to 2.4, your probability will be 0.5. Okay, your probability will be 0.5. This is a 2 point something, any number in between, your probability will be exist. But in continuous case, just you are trying to define what is the area occupied, area under the curve occupied within this particular interval. You don't have any interval, so simple it will be 0. Okay. And in continuous case, you should remember all the time, if you write probability of alpha is less than or equal to x is less than or equal to beta, which is equal to probability of alpha is less than or equal to x is less than beta, which is equal to probability of alpha is less than x is less than or equal to beta, which is alpha less than x less than beta. All the time means that certain interval, it is because of the continuous case, it is including the lower and upper limits all the time. Does not matter whether we include the end points of the interval from alpha to beta. Okay, so based on that continuous distribution function, we'll write. Another point is continuous distribution function. Continuous distribution function. Simple, capital F of x. That is probability of x is less than or equal to x. How you can write? How you can write this one? Integral minus infinity to x f of t dt, where your x is minus infinity to plus infinity. Yeah. Somebody is trying to speak. Okay. So here, even because of the continuous case, we may write, of course, your distribution function will be as usual, lies between 0 and 1, first property. Second one, you can write because of the continuous one, f dash x will be, we can write it is density function because of the continuous. And moreover, it is your capital F of x is non-decreasing monotone. It's a non-decreasing function. Okay. It is a non-decreasing function. That's why. Because it's a continuous one, you are finding your density function, your distribution function, integration of density. The density will be differentiation of your distribution. Simple. And third one is f of minus infinity. How we can write f of minus infinity? Limit x tends to minus infinity, capital F of x. What does it mean by capital F of x? It is limit x tends to infinity, integral minus infinity to x, f of x dx. What does it mean? Integral minus infinity to minus infinity, f of x dx, it is 0. In the similar way, f of infinity, that is limit x tends to infinity, integral minus infinity to x, f of x dx. So that is integral minus infinity to plus infinity, f of x dx. This is your total probability. That is f of infinity will be 1. So since f dash x is equal to f of x, okay, that means dy dx of f of x is equal to density function, so that dfx I can write f of x dx. Okay, so I'll give an example and then we'll stop, and tomorrow we'll discuss about some questions has been asked in the previous question papers. Actually 2023 they have asked 3 questions from this distribution and density and mass function. Okay, just I'll give this, verify whether the following is distribution function, that is capital F of x is equal to 0 if x is less than minus a, 1 by 2 x by a plus 1 if minus a is less than or equal to x is less than or equal to a. It is 1 if x is greater than a. Okay, it is clearly mentioned f of x is a continuous at x is equal to a and x is equal to minus. So first we'll define, because it is a continuous, I can write d by dx of f of x, where I can get d by dx of f of x 0 is going to get relativity, that is 1 by 2a I can get that when minus a to a 0 otherwise. Okay, so because f of x is a distribution function. Capital F of x is a distribution function. Small f of x must be density function. So that we have to show that integral minus infinity to plus infinity f of x dx is equal to 1. If it is f of x dx is equal to 1, then I can say the given function is so integral minus infinity to plus infinity f of x dx. What does that mean? Integral minus a to a f of x dx. So this is 1 by 2a integral minus a to a 1 dx. So this is your 1. So hence capital F of x is a distribution function. Okay, any doubt? Are you there?
Yes, sir.
Yeah.
Yeah, please interact. Complete interact session. Clarification ఏమన్నా ఉన్నా సార్తో ఇంటరాక్ట్ కావాలన్నా మాట్లాడు. యా హారిక, భాగ్యలక్ష్మి గారు, ఎనీ డౌట్స్? ఏమైనా ఇంటరాక్ట్ కావాలనుకుంటున్నారా? ఊహారాణి మాట్లాడమ్మా సార్.
సార్ ఇంకొన్ని ప్రాబ్లమ్స్ ప్రాక్టీస్ చేస్తే కొంచెం ఈజీ మెథడ్స్ గుర్తుండిపోతాయి.
ఓకే మేడం, రేపు ప్రాబ్లమ్స్ అన్ని ఎక్కువ ప్రాబ్లమ్స్ ప్రాక్టీస్ చేపిస్తాను. రాయడానికి కొంచెం ఇబ్బంది ఉంటుంది కాబట్టి డైరెక్ట్ గా నేను పేస్ట్ చేస్తాను. దీంట్లో మీరు ఈజీగా అర్థం చేసుకుంటారు, ఎందుకంటే ఎక్స్ప్లెయిన్ చేయడానికి కొంచెం టైం పట్టుకుంటారు కాబట్టి. రాయడానికి టైం పట్టుకుంటాం, మనకి ఈ రోజు రాయడానికే బాగా లేట్ అయింది. సో రేపు డైరెక్ట్ గా పేస్ట్ చేస్తాను, సో ఈజీగా ఉంటుంది.
ఈ థియరీ కూడా ఇంకా కొంచెం ఎలాబరేట్ గా చదవండి మేడం. దాంతో క్వశ్చన్స్ ఎట్లా అటెంప్ట్ చేయొచ్చు అనే విషయం రేపు సార్ చెప్పేస్తాడు.
సార్ ఓకే.
ఏదన్నా బుక్స్ అదే చేస్తారా సార్? దీనికి ఇంకేమన్నా
సేమ్ అదే బుక్కే నేను సజెస్ట్ చేసిన బుక్ ఎఫ్ఎంఎస్ఏ.
ఇంకెవరే? భాగ్యమ్మ గారు, ఈ మల్టిప్లికేషన్ థీరము, బేస్ థీరము, ఎడిషన్ థీరం మీద వీటి మీద మనం ఎక్స్పెక్ట్ చేయొచ్చా సార్ క్వశ్చన్ సెట్ లో ఇంత డెప్త్ వస్తుందా, కొంచెం తగ్గుతుందా?
ఇంత డెప్త్ కాదు కానీ కొంచెం తగ్గుతుంది. బట్ అడిషన్ థీరం, మల్టిప్లికేషన్ థీరం, బేస్ థీరం అట్లీస్ట్ 4 to 5 క్వశ్చన్స్ ఎక్స్పెక్ట్ చేయొచ్చు సెట్ లో.
వీటి మీద
4 to 5 క్వశ్చన్స్ కన్ఫర్మ్ ఎక్స్పెక్ట్ చేయొచ్చు సెట్ లో అయితే. గ్యారెంటీగా వస్తుంది సెట్ లో.
అవి ఒకవేళ మోర్ దెన్ 1 ఆప్షన్ ఉన్నాయంటే 4.75 మార్క్స్ ఉంటాయి కదా సార్ మనకి?
అవునండి.
4.75 మార్క్స్ అంటే మీరు 4 అన్నా కూడా 4 5 20 నియర్లీ 19 మార్క్స్ వస్తాయి.
మామూలుగా సిఎస్ఐఆర్ లోనే ఓన్లీ ప్రాబిలిటీకి మాత్రమే, ప్రాబిలిటీ డిస్ట్రిబ్యూషన్స్ మాత్రమే 6 క్వశ్చన్ల నుంచి 8 క్వశ్చన్లు అడుగుతాడు.
ఓకే. ఈ డివిజన్ అంటే ఒకసారి ప్రాబిలిటీ దేనికి ఎన్ని అడుగుతున్నారు అప్రాక్సిమేట్లీ?
కన్ఫర్మ్ గా బేస్ థీరం ఒక క్వశ్చన్ అడుగుతుంది సార్.
అచ్చా.
ఈ అడిషన్ థీరం, మల్టిప్లికేషన్ థీరం నుంచి ఒక క్వశ్చన్ అడుగుతారు. ఆ బేసిక్ గా దాని నుంచి ఒక క్వశ్చన్ గ్యారెంటీగా ఉంటుంది. అంటే నేను చెప్పిన ప్రాబిలిటీ స్పేస్ కానీ లేదా డిస్ట్రిబ్యూషన్ కానీ ర్యాండమ్ వేరియబుల్ కానీ ఇట్లా ఉంటుంది. తర్వాత ఇప్పుడు ఈ రోజు మనం డిస్కస్ చేసిన డెన్సిటీ ఫంక్షన్, డిస్ట్రిబ్యూషన్ ఫంక్షన్, మాస్ ఫంక్షన్, వీటిలో నుంచి గ్యారెంటీగా క్వశ్చన్. అసలు లాస్ట్ 2023 మొన్న రాసిన జూన్ లోనైతే 4 క్వశ్చన్లు అడిగాడు. అది రేపు మనం డిస్కస్ చేద్దాం దాన్ని క్లియర్ గా. డిస్ట్రిబ్యూషన్ ఫంక్షన్ చెప్పండి
సార్. చార్ట్ వైజ్ గా కొంచెం టాపిక్ వైజ్ గా ఎన్ని క్వశ్చన్స్ అలాట్ చేస్తారు అనేది వీలుంటే కొంచెం పెడతారు.
ఓకే మేడం,
మాకు ఒక చార్ట్ వైజ్ గా పెడితే ఈజీగా.
ఇది డిస్కషన్ అయిపోయిన తర్వాత నేను క్లియర్ గా నీట్ గా పెడతాను మేడం. చార్ట్ ఒక డిస్ప్లే పెడతాను మీకు. సో మీరు ఒక ఐడెంటిఫై ఉంటుంది అన్నమాట, అంటే ఏ టాపిక్ మీద ఎక్కువ ఏ క్వశ్చన్ ఎక్కువ అడుగుతున్నారు అని.
సార్
ఓకే మేడం.
ఓకే, థ్యాంక్ యూ సార్.
ఓకే మేడం,
థ్యాంక్ యూ వెరీ మచ్ సార్.
థ్యాంక్ యూ.
Okay. నోట్స్ పంపిస్తారులేమా సార్, పంపిస్తాను.
నేను పంపిస్తాను సార్, ఈరోజు పంపించేస్తాను.
ఓకే సార్, థ్యాంక్ యూ సార్.
ఓకే.
సో రేపు కూడా యాజ్ యూజువల్ టైం అండి, టుమారో ఆన్వర్డ్స్ యాజ్ యూజువల్ టైం. మీరు ఇంటరాక్ట్ కాండి, సార్తో మాట్లాడే ప్రయత్నం చేయండి, దాంతో మీకు కొంత నాలెడ్జ్ గెయిన్ చేయగలుగుతారు. వన్ సైడ్ ఉండకుండా బోత్ సైడ్స్ ఉంటుంది. ఓకే శివాని గారు, సౌమ్య, పవన్, వాణిశ్రీ. ఓకే అండి, సీ టుమారో.
ఓకే సార్.
ఓకే.